Today, let us study a new concept called prime factorization. What is prime factorization? Prime factorization is to write a number as a product of its prime factors. There are two methods to find the prime factorization of a given number. 1. Prime factorization by repeated division. 2. Prime factorization by building a factor tree. Let us learn them one by one. Prime factorization by repeated division. Find the prime factorization of 180. To express 180 as the product of its prime factors, we have to begin with the smallest prime number that divides 180. As the number 180 is an even number, it is divisible by 2. We write 2 to the left of 180 and dividing it by 2, we get 90, which we write below the dividend 180. Now we have to divide the quotient 90 with the smallest prime number. As the number 90 is an even number, it is divisible by 2. On dividing 90 by 2, we get 45, which we write below 90. Now we have to divide 45 by the smallest prime number. As it is an odd number, so it is not completely divisible by 2. So now we move ahead to the next prime number, that is 3. Number 45 is completely divisible by 3. 45 divided by 3 is 15. Write 15 below the 45. Number 15 is also completely divisible by 3. That is, 15 divided by 3 is 5. Write 5 below the 15. Now we have 5 as the dividend. It is itself a prime number. So, lastly, on dividing 5 by 5, we get 1. Write the 1 below the 5. Now we have 1 as a quotient. Now we write the prime factorization of 180 as the product of all the prime numbers that we have on the left. Thus, the prime factorization of 180 is 2 into 2 into 3 into 3 into 5. So, we have to follow 3 steps while finding the prime factorization by repeated division method. They are: Step 1. Divide the number by the smallest prime factor. Write the quotient below the dividend. Step 2. Continue to divide the quotient with the smallest possible prime number till the quotient is 1. Step 3. Write the number as the product of its prime factors arranged in ascending order. Now, let us solve one more example. Express 78 as the product of its prime factors. As 78 is an even number, it is divisible by 2. 78 divided by 2 is 39. Next, as 39 is an odd number, it is not completely divisible by 2. But the next prime number, 3, can divide 39 completely. So, 39 divided by 3 equals 13. Now we have 13 as the dividend, which itself is a prime number. So, dividing 13 by 13, we get 1. Now we have 1 as the quotient. Thus, the prime factorization of 78 is 2 into 3 into 13.
Using one more example, and here let's try to factorize 430. So if I want to factorize 430, I'll draw this long line and then a line perpendicular to this, right? And now I'll think about the smallest prime number which can divide this number. So since it has 0 in units place, so it will be divisible by 2, right? So 2 I'll write over here, and 2 2s are 4, 2 1s are 2, 2 5s are 10, right? So we have got 215. Now it has an odd number at its units place, so it will not be divisible by 2, but it can be divisible by 3. So will it be divisible by 3? 2 plus 1 is 3, 3 plus 5 is 8. But 8 is not divisible by 3. That means this number is also not divisible by 3. So it will definitely be divisible by 5 because it has 5 at its units place. So if I divide it by 5, 5 4s are 20 and 5 3s are 15. And this 43 is a prime number which will be divisible by either 1 or 43, right? So 43 1s are 43. And now if we talk about the prime factors, 1 is not a prime number. So these numbers are the prime factors of 430. So 430 can be written as 2 multiplied by 5 multiplied by 43. So what are the rules of finding the prime factors in this fashion? First is divisor should be a prime number, right? And the second rule is you should always start from smallest prime number. So these are the two rules of finding the prime factors of any given number using this method. These are the rules which I usually follow while finding the factors. And definitely there are few benefits of following these rules. First is you will never use any compound number while finding the factors, or you will never find any compound number as the factors. And the benefit of second rule is all the repetition of one number will be found together, right? Like you may have more than 1 2s or 1 3s in the list of factors of a number, right? So if you follow the habit of starting from the smallest possible number as divisor, all the factors which are repeating will come together. And that actually reduces most of the common mistakes while finding the LCMs and HCFs. So let's take one more example of finding the prime factors. So let me remove all this. So now let's find the factors of 27,000. So if I take 27,000, yes, first I'll draw this vertical line and then I'll draw this line. And since 27,000 has 0 at units place, that means it is an even number, and the smallest possible prime number which can divide this will be 2. Yes. So if I divide it by 2, 2 1s are 2, 2 3s are 6, 2 5s are 10 and 2 zeros. And again it can be divided by 2 because again we have 0 at units place, and 13 can be divided 6 times. 2 6s are 12, 2 7s are 14, 2 5s are 10 and 0, right? And now this can again be divided by 2. 2 3s are 6, 2 3s are 6, 2 7s are 14, 2 5s are 10, right? And now we have 5 at units place. So let's check its divisibility by 3. So 3 plus 3 is 6, 6 plus 7 is 13, 13 plus 5 is 18, and 18 is divisible by 3. So this number should be divisible by 3, right? So let me divide it by 3. 3 1s are 3, 3 1s are 3, 3 2s are 6, 3 5s are 15, right? And again we have 5 at units place, which is an odd number. And this number is again divisible by 3 because 1 plus 1 is 2, 2 plus 2 is 4, and 4 plus 5 is 9, which is divisible by 3. So this number will also be divisible by 3. 3 3s are 9, 3 7s are 21, and 3 5s are 15. Right? And yes, it is once again divisible by 3. So let me divide it by 3. 3 1s are 3, 3 2s are 6, 3 5s are 15. Right? And now if I add all the digits, it is 5 plus 2 7 plus 1 8, and 8 is not divisible by 3. Right? So it will no more be divisible by 3, but since we have 5 at units place, so it will be divisible by 5. And if I divide it by 5, I'll get 5 2s are 10 and 5 5s are 15, and this is again divisible by 5. 5 5s are 25, and 5 1s are 5. So all the 2's we have got together, right? And then we have all the 3's, and then we have all the 5's, right? So if I write the prime factors of 27,000, the prime factors of 27,000 will be 2 multiplied by 2 multiplied by 2, 3 2's, and then we have 3 multiplied by 3 multiplied by 3, 3 3's, and then we have 5 multiplied by 5 multiplied by 5, right? So these are the prime factors of 27,000. So those rules are actually to reduce the mistakes while finding the factors, right? So if you follow those rules, it will become your habit, and then you will not do any mistake while finding the prime factors and solving the problems where prime factors are used, right? So bye bye.